Hello everyone and welcome to our capstone project. Our team has been working on a novel bone fixation pin removal device, also known as Osseus. Our project started with kids. Kids have this innate energy within them that pushes them to explore the world and remain active. However, kids also have an innate ability to injure themselves, particularly their bones. In fact, forearm fractures are the most common bone injury in children 18 and under, accounting for 40% of all fractures. To treat forearm fractures, surgeons will use a technique called percutaneous pinning, where they insert surgical pins called K-wires into the region of the bone fracture. This helps to hold the bone fragments in place until they heal and fuse back together. The top of the pins stick out of the patient's skin and are bent for easy removal. However, the main problem and focus of our project arises during the pin removal procedure. Clinicians use pliers or surgical scissors to remove the K-wires, which have poor grip, often slipping off the pin head and increasing the duration of the procedure. K-wire removal can also require multiple clinicians to brace the arm, as well as forceful yanking of the pin until it comes out. All of this can be very overwhelming for pediatric patients, causing elevated anxiety,
We're done. That's it.
fear,
We're done. You're almost done.
and perceived pain.
It's okay. Hey, what are we gonna get at Target?
For the past 8 months, our capstone team has been developing a novel device for KY removal that reduces the pain, anxiety, and duration of the procedure. Introducing Osseus, a patient-centric solution for K-wire extractions. Through stakeholder consultation, we have identified 3 key performance functions and 3 key patient-facing functions that our device must achieve. The device must remove K-wires, decrease procedure time, reduce the input force required from the clinician to remove the K-wire, reduce anxiety, reduce pain, and redefine the standard of care. At this stage of the design process, we have completed our alpha prototype, which is a benchtop model designed to test the performance functions previously mentioned. In the future, we will be doing detailed design to make the device handheld, ergonomic, and aesthetically pleasing. Here is an image of our alpha prototype. It features a high-speed stepper motor, controlled by an Arduino, and a driver. The rotational motion of the motor is translated to linear motion through the rack and pinion, and provides the pulling force required to remove the K-wire. The rack and pinion can slide forwards and backwards thanks to the rack guide and carriage. Now that we've heard an overview of the prototype, let's see it in action. Demo 1 will show Osseus pulling 116 newtons to simulate pulling it against the maximum resistive force of a K-wire. We first filled a backpack with 116 newtons worth of weight, then attached it to our device using a pulley system. Demo 2 shows Osseus pulling 116 newtons for a distance of 6.82 centimeters, just above the average length of a K-wire. Demo 3 shows Osseus pulling a standard K-wire in 1 second, which is 15 times faster than the current procedure. Lastly, Demo 4 shows Osseus reducing the input force needed to pull out a K-wire from 116 newtons to 4 newtons.